Hi everyone. After our enzyme kinetics prac, I had a few requests for a video of me going through the calculations to help people if they got stuck later on when they were looking at their numbers. So this is said video. So one of the first graphs that you need to draw is your absorbances, which you recorded every 10 seconds over 60 seconds. Against the absorbance that the spectrophotometer gave you for each of those substrate concentrations. So this is a very simple line graph. Plot your points on it, draw a linear trend line and extend that linear trend line all the way back to the axis, so where time is 0. That will then give you what was the absorbance at the very start of the reaction. And you need that number to calculate your change in absorbance per minute. So what you're actually trying to establish is what is the absorbance at time 0. And the only way that you can do that is to fit that linear trend line until it crosses the axis and gives you an actual value for there. Now there's a couple of ways you can do that. You can do that by eye, so if you draw these by hand, just draw your line until it extends to the axis and work out what that value is. Or you can fit it in fit the line when you draw it in Excel and get Excel to give you the equation to the line, and that will then tell you what the axis intercept is. So that will look something like this. This is not a real equation, this is just one I'm making up off the top of my head, but it'll be something like this. X plus, let's say it's 0.05. This value here gives you this value here. You can then do the little calculation to work out what your change in absorbance per minute is. So take your A60 value, your absorbance at 60 seconds, minus the value you have calculated here. That gives you your delta A per minute. You can then put that straight into the velocity calculation, which gives you a velocity of the reaction for each substrate concentration. So you've got your delta A per minute times the dilution factor, which in our case is 30, and that is a constant, and divide it by the extinction coefficient for NAD, which is also a constant, so 6.25. So these two values will remain the same for each substrate concentration. The next thing that people might get a bit confused about is how do we work out the assay ethanol concentration. You had a stock solution of 50, 100, 200, 300, 400 and 500 millimolar ethanol. But we did a dilution because we only put 0.5 mils of that ethanol into our total volume of 3 mils. So we need to do this calculation, 0.5 divided by 3 equals 0.17. Multiply that by each of our substrate concentrations, and that will get us what is the actual concentration of ethanol in our tube. So this is in millimolar. You need to do that for each of your concentrations, and then that becomes the x-axis in the other graphs, which I will talk about next.